Hi students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். வாரி மெடிக்கல் அகாடமி சார்பாக இனிவரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய ஃபேக்கல்டி மெம்பர்ஸ் லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் வாரி மெடிக்கல் அகாடமி சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Welcome students. So we are going to see about electromeric effect. Okay. So electromeric effect are nothing but in inductive effects a sigma bond delocalization is taking place. If you have any doubts, you have to refer that video which is dealing with inductive effect. And next one is electromeric effect. So electromeric effect, delocalization of pi bond electrons is taking place under the influence of reagent. Okay. So there is a delocalization of pi electrons is taking place. Only it is possible under the influence of reagent. So if there is no any reagent molecules, then the delocalization will not be taken place as the electromeric effect is explaining. Okay. So the electromeric effect is delocalization of pi electrons under the influence of reagent. See, here is a molecule propene. So where we have electrophilic bond, right? So these bonds are electrophilic. Which type of bonds we can say electrophilic bond? Double bonds, and triple bonds are electrophilic bonds. Okay. So these electrophilic bonds are consisting with pi bonds, pi electrons. So that pi electrons is being delocalized by the influence of reagent. Okay. So here we have one propene, that is alkene. So HCl is a reagent, is acting as reagent molecule. See, there is delocalization is taking place, right? So here the carbon which have positive charge, and here the carbon which have negative charge. So the delocalization is takes place when the pi electrons are shift to this terminal carbon. Okay. So here we have carbon plus and carbon negative, where then the play of reagent will act. Okay. So here the reagent is consist of H plus and Cl minus. The H plus will go and attack this negative carbon. So there we can CH3. And next one is carbon which is in positive state, where the reagent fragment like minus anion will attack there. So then we will get this kind of molecules. Okay. So delocalization of pi electrons is taking place, then the reagent will add up to that molecule. Okay. So we know that this is a hydrohalogenation reaction, right? Hydrohalogenation reaction. Okay, that is nothing but addition of hydrogen and halogen to one electrophilic bond. That is hydrohalogenation reaction. So see, this hydrogen is positive state, carbon is negative state. So opposite signs will be making bond, right? So this positive charge fragment or positive charge ion will add up with this negatively charged carbon. So then it will result CH3. Here only we have CH2. When this hydrogen is added up with this carbon, so it will give CH3. Next, CH plus, here CH plus. So where the Cl minus will go and attack there, so it will make bond CHCl. So you have some confusion. Why, sir? This hydrogen is only going with this carbon. Why not it is not going with this carbon? Okay. So there is a rule called Markovnikov rule. Okay. Markovnikov rule. Markovnikov rule, which says that the stability of carbocation will play. Okay. See, if we assume that CH3, CH, CH2, here minus and here minus. See, this is primary carbocation, right? So this one is primary carbocation, and here secondary carbocation. Okay. CH3, CH, CH2. This is secondary carbocation. Which carbocation is more stable? Secondary one will be more stable. Why? because of the plus A groups. Okay, so this is more stable, then only it makes the secondary carbon as carbocation. That's why here the carbocation will be formed and here the carbanion will be formed. Next, the H will go to minus charge and Cl will go to positive charge. So then we will get this kind of molecule. Okay, 2-chloropropane. So this is electromeric effect, very simple. There is delocalization of pi electrons under the influence of reagent. Here we have reagent as hydrochloric acid. So two types of electromeric effects are there. One is minus I electro, that is negative electromeric effect, and another one is positive electromeric effect. So the same will be explained in this original reaction, right? So when the H plus is added up with this carbanion, that effect is plus E effect, positive mesomeric effect. When the Cl minus is added up with carbocation, that is minus or negative negative electromeric effect. Okay, so there are two types of effects. One is positive electromeric effect and negative electromeric effect. Negative electromeric effect will deals with that adding of negative ion, that is chlorine here, and positive electric effect, that addition of positive ions, that is H plus. Okay, so this is the original or this is the sort of easy explanation for electromeric effect. And here we have to know that as we started, this is temporary effect, right? So temporary effect means it will be after when we taking out the reagent, so this reaction will not takes place because it is only possible in the influence of the reagent, or else this effect will not be named as electrophilic or electromeric effect. Okay, so as we see, there are many examples, right? Many examples we have electromeric effects are witnessed. So where double bonds and multiple bonds, like double bond and triple bonds, are very prone to witness these sort of electromeric effects. Okay, so Markovnikov rule is very important one. Markovnikov rule and anti-Markovnikov rule. So Markovnikov rule. Okay, so this is also the application of electromeric effect. So here one more alkane, the same alkane, one propene. Okay, so here is the reagent is HBr, that is hydrogen bromide. So see the same alkane where we have 2 bromo propane, right? The IUPAC is 2 bromo propane. So here H plus and Br minus, because the Br minus is nucleophile here. Okay, so the electromeric effect, as we see, electromeric effect will be witnessed. So here the positive charge and negative charge. So the positive charge will add up with this negative charge. So the bromine will attack here, and so there we have it. Okay, so next the negative charge is there, right? So here the positive charge will take place, then it will give CH3. So this is the electromeric effect, and we had hydrogen bromide. In addition to that, the result is 2-bromo propane. And next, hydration reaction. So addition of waters are nothing but hydration reactions. So when the water molecule is added up with this alkene, so those sort of reactions can be called as hydration reactions. Okay, so here the fragments are the ions are H plus and OH minus. Okay, so the water molecules will be dissociated into H plus and OH minus. So the same electrophile is H plus and nucleophile is OH minus. So as we seen, which are the groups are electrophile and which are the groups are nucleophile, we have discussed in earlier classes. If you have any doubt, you just refer that videos. Okay, so here the H plus is electronegative and OH minus is, that is electrophile, and OH minus is nucleophile. Okay, so here also the same electrophilic effect is witnessed. So CH plus and O minus. Why this is carbocation is forming here? Because this is secondary carbocation will be more stable. That's why the positive charge will attain, or positive charge will occur in this secondary carbon. Okay, so this is carbocation, carbanion. OH will attack here and H will attack here. Then the result is 2 or propane 2-all, right? Propane 2-all. So it is alcohol. So secondary alcohol. Okay, this is alcohol, propane 2-all. So this is example or explanation of Markovnikov rule and example for the Markovnikov rule. Here the main point is stability of carbocation. Stability of carbocation has to be considered. Okay, so if you see like, sir, the addition of HBr is taking place, the hydrogen is going with the alkene where the hydrogens are maximum. So that is very simple technique, but when they in advanced level, so you have the carbocation, right? So carbocation stability also to be considered, or else you will not get correct result. Okay, so there is some confusion or there is some extra thing that you need to know. So the stability of carbocation has to be considered, then only you will get the very good or very correct answers, or else you will mistakenly choose some other answers, so that will be unfortunately wrong answers. Okay, so this is very important, note this point. Okay, so next one is anti-Markovnikov rule. Here we would not consider the stability of carbocation. Okay, so this is where Markovnikov rule and anti-Markovnikov rule, so which the name itself says against to this rule, right? So stability of carbocation will not be considered in this anti-Markovnikov rule. So here the same HBr, but in presence of peroxides. Okay, this is very important, in presence of peroxides. So in presence of peroxide only, the same reagent and same substrate, but the reaction will be different and it will give different product, right? So only it is possible when the peroxide is there. Okay, so in other words, this is peroxide effect, we can say as peroxide effect or Keres effect. So these two names are another names for this anti-Markovnikov rule. Okay, so same HBr and same propene, but the resultant product will be different. See here 2 bromopropane, whereas here 1 bromopropane. Okay, same substance, right? Propane. Okay, we have changed it, right? So same propene and here propene, and the HBr is same, but there is no any mention of peroxide here, but here we have peroxide. So if the reaction is involving in the presence of peroxide, so it will fall under anti-Markovnikov rule. So then the Br and H plus, here we have H plus and Br minus na. So H plus will go with minimum number hydrogens. Okay, the H plus will go with the carbon which consists of minimum number of hydrogens. Here the carbon and carbon we have, right? So hydrogen and hydrogen, here only one hydrogen, here two. So this is alkene bond. When the carbon atoms are in double bond, you have to consider which one will have minimum hydrogen, then the anti-Markovnikov rules will be followed. So hydrogen is going here and Br minus is going with this carbocation. So we will have, this is carbanion and this is carbocation. So carbanion will add with hydrogen. So it will change into CH, will change into CH2. Correct? So CH will change into CH2. So next one is CH2 plus, this is carbocation, will add up with Br minus, so 1 bromopropane. So here 2 bromopropane, here 1 bromopropane. The only difference is here there is no peroxide and here we have peroxide. So this is Markovnikov rule and this one is anti-Markovnikov rule. Same hydration reaction we have, right? But this one is in presence of diborane. Okay, diborane, B2H6 is diborane, and here also we have peroxide. This is hydrogen peroxide, right? The molecule will be H2. So this is hydrogen peroxide. Okay, so this is also will fall under anti-Markovnikov rule. Here we have CO minus, CH minus and CH2 plus. Okay, so H plus, the water will be added. So the water molecule will consist of H plus and OH minus. So the H plus will go with here and OH minus will go with this carbocation, and we will have 1 propanol or propane 1 all. Here we have 2 all, here we have 1 all, here we have 2 bromopropane, here 1 bromopropane. Okay, so the difference is this is Markovnikov rule and this one is anti-Markovnikov rule. So this is, in other words, we can call as peroxide effect and Keras effect. Okay, so we have many examples, so plenty of examples we will going to deal. So this is just simple explanation for these reactions. So we have many examples and many things we have to work it out, then only you will get the correct answer for these questions. Okay, so if we assume one molecule will fall this hydrogenation or hydrobromination, we will explain in one example, right? Okay, so here we have one more example of alkenes where the hydration is taking place, right? So same the electromeric effect. Okay, so where we can get the we can sense the polarization or delocalization of pi electrons. So here CH2. So where it will follow, if it is follow Markovnikov rule, which one will be the product? We have 2 products, right? So one is this one and second one is this one. So which will be the major product? Have you any idea? So which one will be the most or major product in this? If you think this one is major product, so that is wrong answer. So this one is correct answer, because if we are going to see it, because the stability of carbocation, as we said before, so stability of carbocation will be considered as prime fact. Okay, so see the CH and CH2 is there, right? So H plus and OH minus. So if it is the carbocation is taking place, so as we discussed, the H plus will go with higher number of hydrogen containing carbon. So then this is that carbon, so it will N2 CH2 minus, so it will give CH3. So this is no problem. Then the carbocation will be formed in this carbon, so carbocation. Okay, so there is also no problem. But we have to see, or we have to look into this carbocation is whether it is stable or not. So that is the main point. Okay, so here the secondary carbocation, if this carbocation jumps to there, or if it is turned to be carbocation, it will become tertiary carbocation. Okay, this is tertiary carbocation, which is more stable than this one. So that's why the positive charge will shift to this carbon. Okay, so there we have tertiary carbocation. So then the OH minus will attack this tertiary carbocation, then the OH will add up with this carbon. So we have this product. Okay, and next one is, if we simply or blatantly do Markovnikov rule, so we just simply do that carbon and carbon. So this carbon will have this carbon is having 2 hydrogen. So the hydrogen is going with this carbon and OH is just simply attack here. So it will make the bond. So this is not a correct answer. This one is correct answer, because the carbocation is shifting its place 1, 2 shift. So if we consider this one is 1 carbon and this is 2 carbon. So 1, 2 shift is taking place. So the carbocation is shifting its place to tertiary position. Then we have tertiary carbocation. Then this OH will add here, we will get this alcohol. Okay, so this is very simple reaction, and you have to use your brain, or you have to think it on it, then only you will get the correct answer. Okay, so just simply if you assume that this is the product, then you have to refine your concepts. Okay, so that's why I am explaining somewhat complex examples. Okay, so next one is, here we have one more example. So see, double bond is there, one alkene, one CH3 is there. So what will be the product? If you think that the product is like CH3 and here OH, so if you think that this is the product, that this is also again going to wrong, because if you assume that CH3 is there, right? So one is here plus and here minus. So if or else if you think this is minus, CH minus and this one is plus. Okay, there are 2 pathways. Okay, so if you think this one, or else there are 2 ways. One, this can be minus and this carbon will be positive. So this will not be going to happen, because this one will be more stable. We are going to discuss. So here the secondary carbocation, right? if this carbocation jumps to here, then we will have tertiary carbocation, like so. Minus. Okay, so then the addition of water will takes place, that is H plus and OH minus. Okay, H plus OH minus. So H will go and attack this minus and OH will go and attack here. So the product will be CH3 and OH. So this is the product. Okay, so you have to think, then only you can answer the questions. Okay, so just knowing the concepts or just understand the concept will not going to work. Okay, so if you understand the question or if you understand the concept, then you have to apply in the questions. So whether the applying of questions or the results will be mostly corrective, or else just understanding the concept will not going to work anymore. Okay, so if you understand on concept, just do and work it out, then only you will get correct results. Okay, that is ultimate aim to get in your course. Okay, so next one is, so these examples are enough. So next we are going to see about some more inductive effect, as we see discussed inductive effect. Next one is mesomeric effect. So what are all the mesomeric effect and which types of mesomeric effects are will be ortho para directing group and which is meta directing group, that will be going in, we are going to see again. Okay, so mesomeric effect, in other words resonance. Okay, so here also delocalization of pi electrons or lone pair of electrons is taking place in a conjugated system. So here the word is conjugated system is very important. Okay, so we have know that the system is conjugated. Conjugated means if the double bond is next to positive charge or negative charge, a lone pair of electrons or free radical, then the vacant orbital or electron deficient atoms are centered. So if the system is consisting these categories with this alternative carbon with double bond, then that is conjugated system. See here double bond is there, right? So next is positive charge, the carbon is having positive charge. Here the same double bond and next center is negative charge, and the same double bond and lone pair of electrons. This one is lone pair of electrons, this is free radical, and this one is electron deficient atom. Okay, so if the molecule of the or if the system is consisting this or fall under any categories of this one, then that system can be called as conjugated system. So the delocalization of pi electrons is taking place only in conjugated system. So you have to look that molecule whether it is consisting this conjugated thing or not. Okay, then whether then after that the delocalization of pi electrons is taking place, that phenomena is called as resonance. The effect is known to be resonance effect or mesomeric effect. So here, so again I am reiterating that. So this one is double bond, the carbon next to it having positive charge, and double bond the carbon is next having negative charge, and double bond the next atom is having lone pair of electrons. Here free radical only one electron is there. Okay, you don't confuse with this free radical and lone pair of electrons. Lone pair of electrons, the name itself says it's a pair, then it has two electrons. Lone electrons mean lone, only one electron will be there. So in other words, in chemically we can name it as free radical, this one as free radical. Okay, and boron compounds are nothing but electron deficient compound, because borons can be considered as Lewis acid. So what is Lewis acid? Have you any concept or have you any idea about Lewis acid? Lewis acids are nothing but the atoms or the molecules in deficiency of electrons. Okay, so the boron compounds are well known for Lewis acids, because the boron atom will have lowest number of electrons, then it is can be considered as Lewis acid. Okay, so the double bond next carbon, okay, the double bond and next carbon will have positive charge, negative charge, lone pair of electron, free radical, vacant orbital or electron deficient atom. So any of this category is been explained or is been witnessed in any molecule, that molecule can be named as conjugated system. So where the delocalization of pi electrons is witnessed, then that effect can be known as mesomeric effect or resonance. Okay, so the conditions for resonance is only it has to be conjugated system. Then the net charge, if the positive and negative ions are changed, so the net charge will not be changed. Okay, if we starting material has only one positive charge, then the final system will have only one positive charge. There will be no change in the signs of ions. Okay, so if you consider the well known example is benzene, right? The benzene is C6H6. So here see there are 3 pi bonds. So pi bond, that is a double bond, and next is single bond, then double bond. So this is double bond next to double bond. Okay, double bond next to double bond. This is also one conjugated system. See here double bond and single bond, double bond, then single bond, double bond. Okay, so which can be involved in resonance, correct? So this will go here and it will come. Okay, so delocalization of pi electrons. This is pi bond. So the electrons are in pi bond, pi electrons. So that will be oscillating in this whole molecule. So it will change into like this one. Okay, see the double bonds are changed here. If we consider this carbon as 1, 2, 3, 4, 5, 6. Okay, so here 1, 2, 3, 4, 5, 6. See, in earlier case we have double bond in carbon 1 and carbon 2. Here there is no double bond, only single bond. So because it is get delocalized, the change of the position of double bond is changed. Okay, so from 1 to 2 to 2 to 3, the position is changed because of delocalization. Okay, so delocalization of pi electrons. Okay, so this is resonance. So as we see carbon in single bond, that is in covalent nature, it will have 1.54 Armstrong, and if it is carbon double bond, the bond length will be 1.3 Armstrong, and carbon triple bond, whether it is having so 1.1 Armstrong. Okay, so this is the bond length we know in very first class. Okay, so the carbon is in single bond, the bond length will be 1.54 Armstrong, double bond 1.3 Armstrong, triple bond 1.1 Armstrong. So here one more extra phenomena, that is here the in benzene carbon bond is 1.29 Armstrong. What is 1.29 Armstrong? See, it is not fall under any this sort of bonding, right? So if it is single bond 1.5, double bond 1.3, triple bond 1.1, but here we have some other number, right? 1.29. So this is contrast to this sort of bonding. So where it explains the resonance is taking place. Resonance is nothing but we cannot see in our visible light. This is a hypothetical concept. Okay, so just we are assuming that, see, as we explained, carbon whether it is in single bond, if it is in single bond it should have 1.54 Armstrong, whether it is in double bond it should have 1.3 Armstrong, but here carbon bonding is 1.29. so there is some change, right? So this is your standard bond length, but here somewhat reduced bond length. Okay, so which explains the resonance is taking place. So that three double bonds are oscillating to one carbon to another, then the bond nature is been reduced or the bond length is reduced. See, 1.54 is nowhere in the case of there, 1.39 is also no. So it is will have 1.29. So this bond length reduction is explaining by resonance or mesomeric effect. Okay, so Kekule, the first one who has explained the concept in benzene. So he generally referred the benzene can be known as in this structure. Okay, so we can write the benzene or we can draw the benzene as this one also. So these are all the 3 types. Okay, in 3 different types we can write benzene molecules, this one and this one and this one. Okay, so the different types of structures can be obtained by resonance. There is no change of charge. Without changing the charge, then only the resonance can be explained. If the charge is created, then the charge is destroyed, then that concept or that phenomena cannot be explained as resonance. So the resonance is very important. There will be no net change of net change of charge. Okay, so the charge has to be same in previous case and last one case. So there will be no change in charge. See, there is no change, no charges are there. Here also no charge, here also no charge. Okay, so this is very important one. We have in this canonical structures and resonating structures are same. So if we say canonical structures are and resonating structures are same, so simply we can name it as resonating structures. Okay, so then resonance hybrid, in another one is resonance hybrid. So these two terminologies are very important, resonating structures and resonance hybrid. So what are all those we will going to discuss. Okay, so this is all about the simple concept resonance. Resonance is nothing but delocalization of pi electrons or lone pair of electrons is taking place in the conjugated system. What are all the conjugated system we have discussed earlier? So that the double bond is next we having positive charge and negative charge, either lone pair of electrons or free radical or vacant orbital or empty or electron deficiency atom. So if the system is consist of any of these things, then that system can be known as conjugated system, where if we have any delocalization is there, then that is resonance. Okay, so resonance can be explained in benzene by these bond length variations. Carbon single bond will have 1.54, carbon double bond 1.3, carbon triple bond 1.1. So actual bond length of carbon in benzene will not fall under any of these standard values, because the resonance is witnessed here. This thus changes the carbon bond length into 1.29 Armstrong. So this is simple concept. So you have to very confident or very categoric in this concept, then only you will going to know the extra or advantage topics on this. Okay, so next one we are going to see what is this resonating structure, what is this resonating hybrid, resonance hybrid. So that can be explained in after. Okay, so this is the concept. So next we are going to see about resonating structures and resonance hybrid. Okay, so resonating structures are nothing but by the resonance or due to resonance we are going to obtain number of structures. That structures can be known as resonating structures. So among this resonating structure, which one is more stable, that one has to be considered as resonance hybrid. So the resonance hybrid is nothing but in a resonating structure or among the resonating structure, the most stable structure will be known as resonance hybrid. Okay, so the resonance hybrid is collectively we can take that stable structure of that carbon or that group. See, carbon double bond. So here we have CO2, right? CO2 molecule, that is carbon dioxide, or else we can have CO2. So next here see double bond is there. Next the atom is having lone pair of electrons. So this is conjugated system, is it or not? Is it conjugated system? Yes, because double bond is there, then the next atom is having lone pair of electron. So this is conjugated system where we can witness the resonance, right? So this delocalization of electrons will take place. Whether this electron is coming here, this will go to upwards. Okay, so CO minus and this will have oxygen. Okay, this will have like this structure. Okay, so next again if it is written back to here, this bond is there, then it will go again here. Okay, so this is C double bond O, then O like this one. Okay, so here see delocalization of pi electron is taking place, right? So this lone pair of electrons is coming to this carbon oxygen bond, then it will turn as double bond, right? So these two lone pair of electrons will be utilized to form new one bond. So already we have one bond, extra one bond will result two bonds, right? So next two bonds, then this double bond, because carbon will have how many bonds, students? only 4 bonds it will have, because the valency of carbon is tetravalency. So only 4 bonds have to be witnessed in carbon bond. Okay, so this will come here and this will go up. So this oxygen will be negatively charged. These are next, it is coming here, then it will go here. So here the resonating structure will be like negative charge. We can write this one as resonance. There are three structures, right? This one is resonating structure 1, this is resonating structure 2, and this one is resonating structure 3. Okay, among this, which one is more stable? This one is more stable. That's why we can say this one is resonance hybrid. Okay, so there are 3 types of resonating structure that there. Among these 3, this is more stable because the negative charge is partially involving in these 2 oxygens. So that's why this is more stable than rest of these 2 structures. Okay, so this stability is known as, this stability is establishes this structure as resonance hybrid. Okay, so resonance is nothing but delocalization of pi electrons in a conjugated system, where we can know delocalization is taking place. 1, 2, 3. There are 3 structures are there. Among these 3 structures, this is more stable because the negative charge has been shared by 1, 2, 3 centers. Okay, so mostly in this 3 center, this 2 oxygen is only going to share this negative charge. So the negative charge is been shared with 2 oxygens. That's why this is more stable. So we consider this structure as resonance hybrid. Okay, so this is very important one. So this is all about resonance. Next we are going to see about types of resonance. That is also very, very important. Okay, so which concept we are now discussing, students? This is the electronic displacements. Electronic displacement is involving in covalent bonds. Okay, so we have discussed about inductive effect. There are 2 types of inductive effect, plus I and minus I. And lastly, we have discussed about electromeric effect, plus electromeric and negative electromeric. And now we are going to do about resonance. There are 2 types of resonance: positive mesomeric effect and negative mesomeric effect. Okay, in other words, plus M and minus M. So in resonance, plus R and minus R. Okay, so plus R effect and minus R effect. So firstly we are going to see about positive mesomeric effect. Positive mesomeric effect. Okay, so see, we can consider one benzene. It is bonded with one group, that is alcohol, OH group. Okay, so here you see whether it is conjugated or not. Have you any idea whether it is conjugated or not? It is conjugated. How we can say? Because double bond, next atom is having lone pair of electrons. So this is conjugated system. There the delocalization has been established, right? So if this lone pair electrons comes to this bond, then what will be changed? So this will be forming double bond. So the lone pair of electrons are oxygens. Lone pair of electrons are oxygens are utilized. So that's why it will change into positive charge. Then one more lone pair of electrons will be as it is. Okay, see, then this bond will going to shift here, right? Because carbon will have 4 bonds. If this double bond is staying here, then here double bond and here double bond, one more bond will be there. So 5. That is not possible in carbon, in the case of carbon. So this double bond is shifting to this carbon. So it will be negatively charged. It will form carbon ion. Okay, so the double bonds will be here. Then this this negative charge will shift. It will come here. So negative charge, and it will be like this one. next it will come here and it will go up here, minus charge, and the double bonds will be here, O and positive. Okay, so again, if this double bond, if this it goes here, it will go again here, then it will be same as it is in previous case. Okay, so this is the positive mesomeric effect, because donation of electrons from the groups which is directly connected to the benzene. This is very, very important. The electrons are released by the groups which is directly attached to the benzene, which causes the electron density is increasing in ortho, para and ortho dash positions. So this is known as positive mesomeric effect. So the groups which is only responsible for this effect known to be positive plus R effect plus R groups or plus M groups. Okay, so this is positive mesomeric effect, students. So there will be no confusion to you. Only I am again going to say the groups which is directly attached to the benzene is donating its electron to the benzene ring, right? So the donation of electrons is taking place where the benzene molecule will accept that electron, thus resulting the electron density is increasing. Ortho, sir, what is ortho? The ortho is nothing but the substituent is there na, the next carbon will be ortho, that and again next to ortho, that is meta, and opposite one will be para. Okay, so this one ortho, meta, para. Ortho is nothing but the carbon next to substituent, and meta is alternative to substituent, and the para will be opposite to substituent. Okay, so we have seen that minus charge in ortho position and minus charge in para position, here minus charge in ortho dash position. So which resulting the increasement of electrons in ortho, para and ortho dash positions. Okay, so this effect or this phenomenon known to be positive mesomeric effect. The groups which are responsible for this effect is known to be plus M effect or plus M groups or plus R groups. Okay.